Hi everyone, welcome to this first video on descriptive statistics. I'm Renee Clark from the Swanson School of Engineering. In this first video, we're going to talk about the following topics. What are the two main types of data? The two main types are quantitative and qualitative, and also why it's important to differentiate between them. From there, we're going to talk about the subtypes of quantitative data with some examples, as well as the subtypes of qualitative data with some examples. Okay, so two main types of data. The first is quantitative. The second is qualitative. But the question is, why is it important to differentiate between them? The answer is because this enables you to choose and apply the correct statistical technique for a certain type of data or a certain data set that you might have. Okay. Quantitative data, which is the first main type, consists of measurements and numbers. Okay. There are two subtypes of quantitative data. The first is continuous data, and you've heard this term before. Okay. Continuous data has a whole number as well as a fractional or decimal portion. Okay, so for example, 10.912 kilograms. Okay, the whole number portion is 10. The decimal or fractional portion is the 0.912. Okay. With continuous data or continuous variables, you can specify them theoretically to finer and finer levels of precision. Okay, so this means that any value is possible. So for example, 10.11234667 on and on and on inches is a theoretically possible value. Now, whether you have the equipment to measure it to that level of precision is a different story, but it is theoretically possible to have something that measures that. Okay. The second subtype of quantitative data is discrete data. Okay. Now, with discrete data or discrete variables, it can have only certain or fixed values, which we will describe it more in just on the next slide. Okay. Okay. Still talking about quantitative data. Continuous data consists of things such as height, weight, time, length, temperature, humidity, generally things you can measure. Okay? Discrete data, which as we said can only take on certain or fixed values, can consist of the following types of data. The first is count data. For example, the number of pets you may have in your household. So for example, you could say, I have 2 pets in my household. You can't say you have 2.5 pets in your household, right? Or 3.17 pets in your household. The number of pets or something similar can only be a whole number, right? Another example of discrete data is shoe size. Okay, so for example, in the United States, our system looks as follows. You know, someone might have a size 6 or wear a 7.5, or wear a 9 or a 12.5. Generally, we don't see shoe sizes outside of that, at least in the US system. Okay, neck size would be another example of a discrete piece of data. Dollar amounts are also considered discrete. Qualitative data, also known as categorical data. And this is because with qualitative data, the data comprise categories of a variable, which you'll see what we mean in a minute. There are two subtypes of qualitative data. Okay, the first is ordinal qualitative data. Okay, with ordinal data, the categories are naturally ordered and ranked. Okay, so what do we mean by that? For example, okay, teaching evaluation survey responses or OMET survey responses, okay? You as a student can rank an instructor's effectiveness on a scale, anywhere from strongly disagree about a certain teacher's teaching effectiveness, to disagree, to neutral, to agree, to strongly agree. So there are 5 different categories that measure a particular instructor's teaching effectiveness, and you rank that instructor on one of those 5 categories. Okay. Another example of an ordinal qualitative variable or piece of data would be the severity of one's pain. Okay, it may range anywhere from no pain to mild pain to moderate pain to severe pain. Okay, so as you can see, those pieces of data or the categories are naturally ordered, or there's a natural ranking to them. Okay, this is in comparison to nominal qualitative data, which is the second qualitative data subtype. With nominal variables, the categories have no natural ordering. Okay, so for example, candy color, purple, red, or orange, okay, has no natural ordering. Now, you may like one candy color over the next, but that's a different variable. That would be preference for candy color. Candy color in and of itself has no natural ordering. Another example of a nominal variable would be region of the US, in terms of Western region, Midwestern region, etc. Okay, again, has no natural ordering. It is a nominal categorical variable. We thank the National Science Foundation under Grant 233-5802 for supporting our work. Thank you for watching.